What is up, guys? Merciless bringing you my next YouTube video on for my physics thing that I was talking about. If you haven't seen my first video, it's calculating gravitational acceleration of Minecraft. And as you can see, this is the building that I did it from. But it wasn't a building before. I just made it into a nice building, and there's an elevator up to it. Oh, and then we fell from this little part right here last time, and you just calculate the time. You can find G. Just check that video out if you didn't see it before. But I just made it to a nice looking little building. And I also, for our next experiment, I got the next building, and I made a little nice, like, I'm gonna call it the shooting range, even though it's not really a shooting range, because our next one is going to be calculating the velocity of the bow by shooting it perfectly horizontal, in which it will launch out perfectly horizontal. We're assuming that the bow is from 1.5 blocks high. If you shoot it, so when you shoot it at a horizontal radius or horizontal direction, you'll get a distance of, I marked them off every 3, so 25. Just whatever the tip lands in, that's where it's going to be. And then we're also going to do the dispenser and see how far it goes, and then we'll compare them and see what the difference is. And we're going to calculate it in meters per second, miles per hour. So those are two forms of velocity that are very important. So, like, basically, I'm going to shoot it, because if I'm shooting from a half block high, and that thing's 1.5 block high, and that thing's 1.5 blocks high, where the mouth is, then we're shooting at a straight line horizontally, in which makes there be only a horizontal velocity and no vertical velocity. But of course, the velocity vertically will change because gravity's pulling it downward, and then you shoot it, and then you get a distance. This one was 24. And we'll conduct that experiment 10 times and get 10 different things, and we'll do that one 10 times and get 10 different things, and then I will compare notes. So I'll get back to you when I got the data and stuff. Okay, I'm back, guys, and this is the PowerPoint to represent the mathematical representation of my lab experiment. So here we go. So launch velocity of the bow and also the dispenser. So we're going to start off with the bow and talk about the idea of two-dimensional motion. And in two-dimensional motion, the x components and the y components are completely independent from each other because one's vertical, the horizontal has no effect on the vertical, which means so gravity, such as gravity, has no effect on horizontal movement, only on vertical, and vertical things like the motion of the ball of the arrow has no effect, like air resistance, because it's moving horizontally, so it means air is acting horizontally also, which means air resistance has no effect on y dimension, in this case at least. So to start off, we have two equations that we'll need for the lab, and the first one will help us find the velocity x, which is what we're wanting because we're shooting horizontal, which means velocity x is launch velocity. And then we have time, which I'll show you later, and we measure distance in the lab. So to use this equation, the second equation, we can deduce it down like we did in our first video to show that we can find, in this case last case we were measuring time, but this case we're going to find time using the other variables. So the first thing is that v sub 0 in the y direction is 0 because it's shot horizontally, which means there's no y component. And since we know where the bow is about 1.5 meters off the ground, we're going to say y sub is 1.5. And we calculated g last episode, which is 26.59 meters per second squared. And so if we take this equation we deduce it down. We take down the middle term because v sub 0 sub y is 0, and then we also substitute a g in and y sub o. We get this equation, and since we know y sub t at t is 0, which is which is when t equals the time that it takes to fall to the ground, we can put 0. We add this term to the other side, and then we divide that term. We just solve for t basically, and then we get this 0.336 seconds, which is the time it takes a arrow with this g value to fall 1.5 meters. And so we can use this equation to find the launch velocity, because we have the distance that's which we measured in the lab. So we got an average of 24.2 meters per second. Meters, sorry. I'm getting ahead of myself. And then the launch velocity averages out to be 72 meters per second. Now, the conclusion is that it's the launch velocity, as I said before, is about 72 meters per second, which is about 161 miles per hour. Now, as we calculate the launch velocity of the dispenser, it's the same exact thing, just different distances over a different distance, because the dispenser is nowhere near as powerful as a bow at its max. I mean, of course, you could shoot it shorter if you don't pull it out to its max, but if you hold on to it until it goes out as far as it can go, then you can find the max velocity. But as the dispenser goes, it only shoots one velocity because it's just activated by a redstone signal, and it averages out to 12.2 meters, and the velocity averages out to 36.3 meters per second. And 36.2 meters per second is about 81 miles per hour, which is a little less than a major league pitcher. And I'm not sure if there's a correlation between the launch velocity of the dispenser and the launch velocity of the bow, but it seems to be half of the launch velocity of the bow, because if you multiply this by 2, you get about 162, which is very close to what we got, which is 161.1 miles per hour. So yeah, that's basically it. So here, I hope this has been helpful, and I guess if you're studying physics, this is a good lab to do. You can do it yourself with whatever you want in real life. You can measure like water coming out of a pipe or anything like that, and see how far it goes. But you have to know the velocity, or if you know how far it goes, then you know the velocity, anything like that. So I hope this has been helpful, or if you found this is recreational, because Minecraft, everybody likes Minecraft for the most part. So thanks for watching. Please subscribe and like.